Hello. Yes, we welcome you back to PSSB, Physical Sciences, Survivability with me, Richard here. Okay, we are looking at this question. It says that the diagram below shows the setup for electrolysis of copper 2 chloride solution using graphite electrode. Okay, this is the setup we have. Then we come to this question. It says that the graphite electrode in the cell above, which is this cell, was replaced with copper electrode. And they say, write the reaction at cathode, or write half reaction at cathode. So you have to know that what we have here is an electrolyte, copper chloride. So it's copper ions and chloride ions. And according to the mechanism of conduction, positive move to negative. So positive ions move to the negative electrode, and negative ions move to the positive electrode. So we are looking at cathode here. Cathode is the one which is negative. And which ions are moving there? It is copper ions. So what happens here? So when copper ions reach cathode, they are reduced by taking up 2 electrons to become copper solid. Yeah, then we come to this one. It says that write half reaction at anode. Okay, A happens to be our anode. And we said chloride ions moved there. We need to remember that we have replaced graphite with copper at both electrode. So which means that this one is also copper. So when it's copper and chlorine, when it's copper and chloride ions move there, something happens. They move there, but they are not discharged. Instead, something else happens. The electrode itself, which is now copper, undergoes oxidation. So it is going to be copper solid, becoming oxidized to copper ions. Yeah, like that. So this is the reaction which takes place. No chlorine gas is formed if this electrode is copper. Yeah, then we come to this one. It says that state the observable change at A. So this is A, which is anode, which is positive. So what happens at A? We observed that copper electrode underwent oxidation. Oxidation means that copper solid changes to copper ions. So this is the reaction which took place. It is copper solid turning into copper ions. Now I need you to know that every time you have a solid electrode turning into ions, that means that the size of the electrode decreases. And that's the observation. So what's the observation? The size of the electrode decreases. Yeah, now we are looking at this observable change at B. What do we observe at B? Okay, this is what you have to know, that B is our cathode. And cathode is reduction. So in other words, we're having copper to ions changing to copper solid. Okay, Yes, we must not forget the 2 electrons here. So this is what we see. This is the reaction which takes place there. And the question is, what does this reaction leads to? So we need to observe that every time you have solid as the product of the half reaction, it means that that electrode is increasing in size or mass. So what are you going to say? The size or mass of electrode increases. Yeah, then we come to this question. It says that the blue color of copper-2 chloride remains unchanged. Give a reason for this. Okay, when you replace our graphite with copper on both electrodes, the blue color does not change. It remains unchanged. And why? Why does it remain unchanged? Okay, the answer is that the rate of oxidation at anode is equal to the rate of reduction at cathode. Okay. Okay, then now we come to this question. It says that state and explain the difference in observation at A when graphite is replaced with copper. Okay, what is the difference? The difference is that when graphite is there, chlorine gas was formed at A. And when graphite was replaced with copper, it's copper which underwent oxidation, so reducing in size. Yeah, this is it. Yeah, with chlorine, with the graphite electrode, chlorine gas forms. With copper electrode is oxidized, so reducing in size. So what is the reason? The reason is that copper is a stronger reducing agent, so it is preferably undergoes oxidation compared to chloride ions. And with that, I would like to thank you for your time. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. So stay with us. We believe you want to be great. See you next time. Bye-bye.